G'day everyone. So this one here is we're going to be looking at combining transformations with matrices. So in this question here we've got express a reflection in the x-axis, dilation parallel to the x-axis by a factor of 0.5 and a translation 3 to the right and 2 up as a single transformation, and find the curve that y equals to x cubed is mapped to under this transformation. So there is a lot of information in this question that we do need to break down first. So we'll just do that now. So first off, I'm just going to highlight all our important information. So our important information is what kind of transformations we're looking at. So we've got reflection in the x-axis. I'm going to do all these different colors. Then dilation parallel to x-axis, and this is by a factor of 0.5. And then a translation of 3 to the right and 2 up as a single transformation. Okay? So that's one part of the question. There is all the types of matrices you need to set up. And then the second part of the question is we need to find the curve that y is equal to x cubed is mapped under the transformation. So it's just saying, what does that turn into? This y is equal to x to the power of 3, what does that turn into? So that's essentially breaking down the whole question. So first we need to set up our transformation matrices. So we start off just by having our x and y. So first we've got a reflection in the x-axis. So reflection in the x-axis, this is this matrix here, okay? So we just write that one out. So this one is 1, 0, 0, -1. Okay? Then that's our first one. Our dilation parallel to the x-axis. So this one is a little bit harder to understand, and it's just looking at the language specifically. So dilation parallel to the x-axis. So this is actually this one here down the bottom, where it's dilation by factor k from the y-axis. So they can change the language a bit in these questions, but from the y-axis is parallel to the x-axis. Okay, so that's just something to look out for that. Okay, so that's this one here, and that's 0.5 is the k value. So we sub that in, 0.5. Okay, and then our next one's our translation. So we put our xy here, because remember your translations is plussing these x and y values. So your translation of your x and y, and this is 3 to the right, so that's positive 3 here, okay, and 2 up, so that's positive 2 there. Okay, remember x is left and right, y is up and down. So these are all our matrices. Now we need to combine these two matrices here as our next step. So that's our next step here, is combining those two. So how we do that, just remember you can write this our transformation xy as our x dash y dash as well. Okay, so you can write it like that. So here we're combining these. When you can do this by hand, but hopefully if you've multiplied some matrices before, you are quite familiar with these ones here and multiplying them together. So this one will just end up, and you can do it on your CAS to check, but this one will equal 1 times 0.5, which is 0.5 in this top one, and then they'll all be zeros in these two here. Okay, you can do it the long way and double check this, and then negative 1 times 1 in this one, which leaves negative 1. Okay, so combine those two are equal to that, and then we're left with our xy plus 3 and 2. Okay, so now what we need to do is multiply these two matrices together. Okay, so remember this works because this is the first one's a 2 by 2 and the second one's a 2 by 1. So this is going to form a 2 by 1 matrix after this. Okay, so here and you'll notice also with this, when we've got 0.5 and the x on the top, that these two will just combine. Our negative 1 will affect our y down the bottom. Okay, yet again, you can double check this on your CAS or do it long by hand and double check it that way. So feel free to do that if you need to. Or check out some other videos on how to actually multiply them if you are having trouble with that. Okay, so this will then go to x over 2. So that's half of x. I'm just writing as a fraction here now. And then negative 1 times y is negative y. And this is going to be plus 3 and 2. Okay? So now we can actually combine these matrices together. Okay? So just remember, whenever you're adding fractions, they need to have the same denominator. So this here 1 here, 3, just remember, that becomes 6 on 2. Alright, so just make sure that you are doing that when you are putting them together. So this will then come down to x plus 6 on 2, and then negative y plus 2. Okay, remember this is your x dash, y dash. Okay, so I'm just going to go down a little bit now. So now we can write two equations from this. So we can write our x dash, so x dash is equal to x plus 6 over 2, y dash is equal to negative y plus 2. Okay, so now you need to rearrange to solve for y and x. So that just means getting the x and y by themselves. Okay, so this first one we multiply 2, so this becomes 2x dash is equal to x plus 6. Then I'm just going to switch around to this to make x on this side and minus 6 from both sides, because this becomes 2x dash minus 6. Okay, sorry, that looks like a power of a 1 rather than a dash. Change that. Okay, now y, so first we minus 2, and then we all multiply or divide by negative 1, and I'm just going to put the y on this side, so it just changes it to 2 minus y dash. Okay, so now where they're actually transforming with the x and y and what's happening for each variable here. So now we just need to go back up to the top of our question, and this is where our last bit of information comes in. So we need to find the curve that y is equal to x cubed is mapped to under this transformation. So just double check. So y is equal to x cubed. So we have y is equal to x cubed. So now all you need to do is sub in your values for x and y. Okay, so here our first one, y is equal to 2 minus y dash. Okay, and sorry, after we do this, we go to, I'll just say it now, then we go to get y by itself. Okay, so or y dash. Just like any other function that you would, how we have y by itself, so we'll get y dash by itself. Okay, so we're going to sub in y, so what subs in is 2 minus y dash. So 2 minus y dash. Okay, and then our x, just remember all of this is being cubed, so this is going to be 2x dash minus 6. And all of that is going to be cubed there. So here we can break this down a little bit. So here we've got, I'm just going to cube this 2 value out the front and chuck that out the front there. So 2 cubed is 8. So I'm just going to do that. And take out a factor of 2, sorry, I'll do that first. So just taking out a factor of 2 here. So that becomes x minus 3 in the bracket. Okay. But because then it's getting cubed, so we've taken out this factor of 2, but then this is going to be cubed as well. Sorry, that should be a 2. So essentially it looks something like this. And this is a very easy mistake to make. So I've taken out a factor of 2 here, but that still needs to be cubed after you take it out. Okay? So just make sure you are doing that. So then this becomes 2 minus y dash is equal to 8, and then x minus 3 cubed. And then we just need to get y dash by itself, so then this becomes negative y dash is equal to 8 x minus 3 cubed, and then we had to minus 2. Just need to scroll down a little bit further, and then we just need to multiply it all by negative 1. So y dash, so all I'm going to do is chuck the 2 out the front because that becomes negative 2 to positive 2, and then we need to minus our all of this together. Okay, so just make sure you're minusing all of that together. Why is that not going away? Anyway, that doesn't want to go away for some reason. So then this becomes 8 x minus 3 cubed. Okay, so this is actually the image of all the transformations. So hopefully this helped with doing these types of questions, and I can quickly just go through everything again. So firstly, just make sure that you get all your right transformation matrices up here, okay, putting in this format. So your dilations and your reflections, those types of things first, and then your transformations at the end with the plus, okay? So they're your transformations at the end, okay? Combine your dilations and reflections, that matrix there, then multiply it with your x, and then combine those two there. So with this, it is important just to follow those steps there and making sure you are doing it that way. So then you've got your equations, you just need to rearrange them. Hopefully they're pretty straightforward to rearrange in most cases there. So then you rearrange your equations. So that's just right here, rearranging your x and y values that you got here under your transformations. And then when you have it as an x and y value, you just substitute these back into your equation that you're given at the start. And then you just need to get your y dash by itself, and for some reason it's erased itself down here. Okay, but just remember, this is a very tricky part here. If you're taking out a factor of 2 or something from your brackets, just make sure that you do whatever it was supposed to do to it outside the bracket. So if it's squared, that you square it. If it's cubed, that you cube it as well. Okay, just make sure you are doing that little step there. That can be a very easy mistake to make. So just make sure you are doing that right. So good luck with that, and hopefully you can feel a bit more confident in applying transformations to matrices.